So number 37, I'm going to factor that to x minus 1 and x minus 1. Cancel one of them out. Well, what do I leave on the top? 1. 1 over x minus 1. Well, if I directly input 1, do I still get what in the denominator? 0. So now I'm going to go to the right of 1, which is what number? What's right of 1? 2. 2 minus 1 is? I get a positive value, don't I? So my answer is what? Positive infinity. Very good. Number 38. I'm going to plug negative 1 in. Negative 1 squared is 1, plus negative 5 is negative 4 plus 4 is 0. So I'm going to use a toolkit strategy. Which one stands out to you on this one? What stands out to you? Factoring. Very good. So it'll be x plus 4, x minus 4, and on bottom, x plus 4, and x plus 1. Cancel that out. I'm going to directly input. Well, if I directly input negative 1, I still get 0, don't I? Alright, so I'm going to go to the left of negative 1. What number is to the left of negative 1? Negative what? 2. So I'm going to plug negative 2 in. Negative 2 minus 4 is? Negative 6. Negative 2 plus 1 is? Negative divided by negative is a? So you get positive infinity. You said, Mr. What if I just went back and plugged negative 2 in the whole thing? You should still get positive. Because I plugged negative 2 here, I'll get a negative on top and a negative on bottom, so that would still give me a positive infinity, won't it? Do you see that? So you can plug it either into this or the original. Alright. Number 39. I directly input 4. I get what in the denominator? 0. So I'm going to factor it. I'm going to cancel this and this out. Okay, you always try, after you do your toolkit strategy, you try direct substitution one more time. I plugged in 4. Does 4 work? So can I do direct substitution? So 4 plus 5 is? 4 plus 4 is? So your answer is 9/8. Do y'all see that? Alright, number 40. I plug in 0. Can I have that? No. Can I do any toolkit strategy? No, so here you know it's going to be either positive infinity or negative infinity. I go to the right of 0, which is what? Go to the right of 0, which is what? 1. 3 times 1 is? 3 minus 1 is? 2 over 1 is what? So that's going to what? Are there any questions? Alright, now I want you to turn to, so y'all good with as x goes to numbers, aren't you? Now, today, let's look at our learning target. I can determine limits at infinity. So instead of being numbers, you're going to start seeing infinity symbols. Positive, negative, infinity. So I want you to turn to page 7. Page 7. Page 7. Alright, we're not going to look at this because this is confusing. I don't like that way of teaching it, so I'm going to teach it my way. Find each limit. What type of functions are these? You will make my day. Somebody said quadrat. I hear that. What's another word? Cubic. But what's that whole family called? Polynomial. Can you tell these are all polynomial? The powers family. You got, what type is this? What type is this? What type is this? I'm so proud of y'all. Remember that. Good job. Alright. So these are all polynomials. This is what you do with polynomials. You remember us back in the day talking about the end behaviors? What the ends were doing? Okay, so if it was an even power, and the leading coefficient positive, take your hands and show me where the ends are going. Good job. Keep going. I need everybody. Everybody. Come on. Okay. Now, if it's negative, what are you doing? Where are they going? Okay. If it's odd, show me the positive. If it's negative, do what? Do we remember that? Okay. You're going to have to sketch a picture. Sketch a picture. So our number one, you said it's what, guys? It's cubic. And so I just sketch a picture of a cubic function. Do you see that? Sketch you a picture. Nothing perfect. Now, if it had been a negative leading, this is the leading coefficient 1. If it had been negative 1, I would have drawn that way. Y'all remember that? This is positive in front of x cubed, so it goes this way if it had been negative. Now, it says as x goes to negative infinity. If I go this way, where's my y values going? Down. That means down means what infinity? That's your answer. Number 2, what type of function is this, Sarah? Quadratic. Now, what's your leading coefficient in front of the x squared? Negative what? So you're going to draw a regular one or a downward? Downward, not an upward. You're going to draw a downward. So I'm going to look here, and I'll just sketch me a picture. A downward parabola. As x approaches infinity, where's your y values going? So what infinity is that? Negative infinity. Number 3, what type of function is this, Will? Quadratic. There you go. What's my leading coefficient here, Caitlin? Positive or negative? So, Mary Catherine will be upward or downward? Upward. So, sketch you an upward picture. As x goes to negative infinity that way, where's my y values going? So, up means which way? Positive infinity. That's your answer. These are super easy, aren't they? Alright, number 4. What type is this, Max? Not quadratic, but quartic. And remember, it's still going to be that general shape, something like that, isn't it? Alright, as x goes to negative infinity, where's your y values going, Matthew? So what infinity is that?
Positive.
Thank you. Number 5, what type is this, Scotty?
5 is a
quintic. My leading coefficient is what, Lucy?
1.
It's positive, so it's still going to be something like that, isn't it, guys? I'm not care about all that. I'm just caring about my ends. Alright. As x goes to negative infinity, as I go this way, as I approach negative infinity from this way, where's my y values going? Which is? We're going to say negative infinity. Yep, that's negative infinity. Number 6. What type is this, Caitlin Roberts? Cubic. My leading coefficient is what, Luke? Positive. So it's going to go like this. As x goes to positive infinity, Gracie Strickland, where's my y values going? So what does that mean? Thank you. Are there any questions on how to do polynomial functions x goes to infinity or negative infinity? Alright, turn to page 11, and I want you to do number 43 right now, 47, and 50. Do those 3 right now, then we're going to go over it. 43, 47, and 50. Should take you no time. Huh? You need to draw it to be able to see what's going on, don't you? Yes. Guys, all these are going to be mixed up in your test Friday. You're just going to be able to look at a situation and say, okay, this is going to infinity, negative infinity. I need to sketch a picture. 43, 47, 50. Take your grand total a minute. Look up when you're done. One more minute. Posky, what type of function is number 43, buddy? Very good. What can you tell me about the leading coefficients, constants? On 43. It's positive. So is it going upward or downward, Alyssa? Very good. As I go to negative infinity, what is going on, Christian? Where's it going to? My y values. Very good. Are there any questions? Number 43. Number 47. What type of function is this, Olivia? Cubic. Very good. Gracie Coco, what can you tell me about the leading coefficient, huh? It's positive. I'm increasing like this. As I go to negative infinity, what's going on, Lane? Very good. All right, number 50. What type is this, Shad? Quartet. Very good. What can you tell me about the leading coefficient, Catherine? Positive. Very good. So I draw it something like this. As I go to positive infinity on the x-axis, where are my y values approaching, Ryan? Very good. Are there any questions on that exercise? Okay, let's look at rational functions now. Okay, so the only type of function you're going to deal with as x approaches infinity or negative infinity is polynomial. That's the rules for polynomial. And then we're about to learn the rules for rational and call it a day. Okay. Let me give you an example here. Top heavy. What do I mean by top heavy? Let's say I had this right here. What's my degree in the numerator in this particular problem right here? 2. What's my degree in the denominator? Do you see the higher degrees in the numerator? That's what it means by top heavy. When you approach positive or negative infinity, then it's going to be either positive or negative infinity. That's going to be your answer, either positive infinity or negative infinity. Now, how would you determine that? Well, guys, if I look at this particular function here, and I'm going to positive infinity, I'm going to pick some number way down the line. I'm going to say 100. 100. If I plug 100 in for this x, would it give me a positive or negative value? Positive, wouldn't it? So I'll be going to positive infinity. Does that make sense? If I said the limit to negative infinity, then I would plug a negative 100 in there. Well, if I plug a negative 100 in there, that will give me a positive value in my numerator, but a negative in my denominator. What's the positive of a negative? It'll be negative infinity. But if you cannot see that, you can always graph it and look on the graphing calculator, okay? This is the hardest type, is this first part. If it is bottom heavy, for example, it doesn't matter what infinity it's going to. If it's bottom heavy, let's say x plus 3 and we got x squared minus 4, then it always goes to 0. The limit is 0. If it is bottom heavy, it's always 0. You have a choice. You have to between positive infinity or negative infinity. If it is equal, if it's equal, degree 1, you take your leading coefficient here and just divide them. That would be equal to 2, okay? So if it's equal, leading coefficient of numerator divided by leading coefficient of denominator. Like on number 7, its limit is x goes to infinity. I can't do direct substitution here because it's going to infinity. I don't have a number to plug in, do I? So don't be trying to do direct substitution on these. This is how you know you got to do something different because there's not a number there to plug in, is it? So x goes to infinity. So I'm going to just pick some random number down the infinity road. I always pick 100. If I plug 100 in there, would I get a positive or negative value on the top? What would I get on bottom? Positive out of a positive is a negative on to positive infinity. Now, once again, you don't understand that. Let's get the graphing calculator. If I was to graph this, I always go, if you ever doubt, just go to graph calculator to see what picture you're getting. As x continues down to infinity, where's that graph still going to? It's still going to infinity, isn't it? Keep going and going. That's why it's positive. Alright. Number 8. What's my degree in the numerator? 2. What's my degree in the denominator? They are the same, so what do I do with the leading coefficients? Divide them as 3/2. Doesn't matter what infinity is approached, positive or negative. That's the rule. Number 9. What's your degree in the numerator? Degree in the denominator. What's 4 divided by 8? That's your answer, 1/2. Number 10. What's your degree in the numerator? Degree in numerator. Degree in denominator. It's bottom heavy, so what's your answer? There's your limit. That's as hard as it gets. We just covered everything that's on your test. Juicy. We're just reviewing every day. Are all good? How do you feel about determining limits at infinity? I need a hand signal. Okay, so you looked at polynomial and rational. Polynomial, you draw a picture. Rational, you got these 3 rules, okay? So you got to learn that. Okay, you're not going to have any homework, but let's keep working on this. I want you to turn back to page 11. Omit 42. I want you to do 41 and 44 right now. 41 and 44. (41 and 44). (41 and 44) on page 11. Take you a grand minute to do these. Now, if it was if it was top heavy, if it was top heavy and you were going negative, I would plug in negative. Number 41. What's your degree in the numerator, class? 2. What's your degree in the denominator? 2. So what do you do with your leading coefficients? So what's your answer? 4. Very good. Okay, 44. What's my degree in the numerator? What's my degree in the denominator? Is it bottom heavy or top heavy? So this is where you have a choice between the answer to positive infinity or negative infinity. So look, I'm going to positive infinity. So I can just randomly put 100 in there. Let's see what's going on. If I put 100 in there, would that give me a positive or negative value? So it's going to what infinity? Very good. Alright. Number 45. Do 45 and 46. You got those done there? Erase your hand off the floor back there. Number 45, what is your degree in the numerator, class? Degree in the denominator. What do I do with the leading coefficients? So what is it equal to? Very good. 46, degree in numerator. Degree in denominator. Is it bottom heavy or top heavy? So this is where you have a choice between positive infinity or negative. Let's observe, it's going to what infinity? If I pick 100 in there, would that give me a positive or negative value? So it's going to what infinity? Very good. Do 48. Yes. I'll plug a negative 100 in there. Okay. And then just see what it will happen. Okay. How was the quiz today?
One bad.
Which one was bad? Oh, I thought you said it was one bad.
I mean, I got stumped on one of them, but I figured it out.
What's wrong with rationalizing the numerator?
That one wasn't the one that stumped me.
Y'all need to go home and learn to rationalize it. I was thinking it was the complex fraction.
Yeah, that's what I was thinking.
Well, was there only one rationalizer on the test? And that one gave you trouble? Well, guys, there are a lot on that test, so we need to go home and learn how to rationalize now. That's not a joke, no. Yeah, but that complex fraction, I was wondering about that one. All right. Have we did 45? Have we did 46? Okay, 48. What's your degree in the numerator? Degree in denominator? 2. It's top heavy. So we say n going to infinity. So I put in 100. Is that going to give me a positive or negative value? So it's going to what? Very good. Number 40, do 49 and 52. Do 49 and 52. First and last one.
So in the one where the coefficients are equal, you should divide. If it's approaching negative infinity, would that be a negative 2? Or
No, it doesn't matter. You just divide the coefficient. It doesn't matter what you infinity, you just divide the coefficient. All right, number 49. What's my degree in the numerator? Degree in denominator? 2. Very good. It's top heavy. So this is where you have a choice between positive or negative infinity. It's going to infinity. So what would you substitute in there? 100. What kind of value would you get? Positive. I don't care what the value is. I'm just looking at the sign. So it's positive infinity. Yes, ma'am.
So if that was a negative 100?
And then I will put, if it was negative infinity, I'll substitute a negative 100. All right, number 52. What's my degree in the numerator, class? Degree in denominator. So what I do with the 2 and 4, and it gives you. Very good. Good job, class. You can pack up. Tomorrow we're just practicing. No homework. Learn one like what? That one, all you could do is graph it on the graph calculator and look at it.
But technically, when you say that